What's the value of each expression? My best suggestion for how you should approach this is to expand these out into their prime factors, okay? Now, with roots, and you can see this is square root because it's got a 2 there. Typically, you won't see that 2 there. You will just see the root symbol without a number on the outside if it's a square root. It's kind of like having a 1 in front of an x. You don't write it, or a coefficient of 1, or rather an exponent of 1. You don't write it if it's just square root. You will see it if it's something else. So, for example, on 13 and 15, you see that 4 there. You need to put the 4. You need to put the 3. Okay, but you don't need to put the 2. You'll eventually just see that written as like that, and you'll know that that's an implied 2, right? You're square rooting it. Okay, but anyway, they're writing it now, just so you're clear. And what we're going to do is we're going to break down 49 into its prime factors. If we said 49 is what times what, and we do it until we get primes, and actually 7's prime. So what we get inside is actually, this is just 7 times 7. Okay, that is 49. Hopefully you can see that. And the idea here is this. When you root something, you're essentially saying, if I was to write it out in expanded form like I just did, the root that you're doing it to, the square root, tells you how many times you need to see it inside the root symbol in order to bring it out. So if you see a number in twice, because there's a 2 here, that's the square root. It says, if you see it twice, bring it out once. So I'm going to say, I'm going to cross out those 2 7's, and there's nothing left inside, so it's just simply 7. And hopefully you know that the square root of 49 is 7, right? Because the square root says what number times itself 2 times equals 49, and 7 times itself twice, or 7 times 7 equals 49. That's a pretty straightforward example. And then as it gets a little bit more complex, you hopefully can continue to extend that same idea. So let's do this one. If we were going to do the prime factorization of 625, you might know that, okay, well, that's we know that it ends in 0, 5, so then we know that there's a 5 there, 5, and then if you need to, you can just do the division to see what the other number is that's on the other side. So 5 goes into 6 once. If you needed to do this, you might already know what it is, but 5 goes into 12 2 times, that's 10. And 5 goes into 25 5 times, okay? So you can say that's 5 times 125. And of course, you circle 5 because it's prime, and 125 gets broken down further because it's not prime. Let me erase all this stuff. Okay. And you may already know this, that 125 is just 5 times 25. 5's prime. 25 breaks down into 5 and 5. And there you get it. So what you've got here then is you are looking for what they call the fourth root, because it's a 4 out there. The fourth root of 625, which actually breaks down to be 5 times 5 times 5 times 5. Well, since you're looking for the fourth root, essentially what that's saying is you need to see the number under the root symbol 4 times in order to be able to bring it out once. So again, this says 4 there. That means you need to cross off 4 of whatever number it is that you're bringing out. And you can see, then we can say, okay, we can cross off that 5, 1, 2, 3, 4 times. And now we can bring out a 5 because we crossed it off 4 times. And there's nothing left inside, so it's simply just 5. I'll box these answers out. And we're going to do the same for 216. And 216 is actually a fun one because it's not just the same number, okay? You'll see what I mean in a second. So what we're trying to do is we're trying to say, what is the third root of 216? So let's break it down. Well, I know that it's even. So I know that I can say 2 times half of 216. Half of 200 is 100. Half of 16 is 8, so 108. Okay, and 2 is prime. I can break down this again into, I see it's even, so I can do 2 times what? Well, half of 100 is 50, and half of 8 is 4, so 2 times 54. 2 is prime. And actually, I know that this 54, that's 9 times 6. So I'm going to break that down into 6 and 9. I know that I've kind of jammed it in here a little bit. My apologies. And neither of one of those are prime, but 6 is 2 times 3, and they're both prime. And 9 is 3 times 3, and those are both prime. Hopefully you know your primes, at least the prime numbers that are single digit, less than 10, right? Those are 2, 3, 5, and 7. So what do we got? We've got, let's see, 2 times 2 times 2. You see 3 2's down there, and 3 3's. 3 times 3 times 3. Okay, and oh, I didn't write it, but I should have. I should write there that this is the third root. That. And what that means is then I need to see a number 3 times inside before I can bring it out. So I see a 2 3 times, so I can bring out a 2. And I see a 3 in there 3 times, so I can bring out a 3. Nothing's left, so it's just going to be the whole number that I get when I multiply 2 times 3, and what I get is 6. So that is the value of each expression. I suggest that you do it this way until you really, unless you really are familiar with the numbers. Like you might be familiar with the square root of 49 is just 7, right? What number times itself twice is 49? It's 7. And you can just write it if you know it, but for now, expand it out like this if you need to.